Okay, let's continue with 7.2. Second part. We're going to work on translations of rational functions. So translations means what type of transformation? Up or down or left or right, okay? So the equation is going to look different from what you guys did for homework or didn't do for homework. Just saying. Okay. So any function, I'm going to cover the rational function for now. Any function and then a minus sign at the end. What's going to happen? It goes down 1 unit, right? You know that. Okay. Right now, the ones you did yesterday, they didn't have any translations other than a shrink or a stretch. This one's going to go down. So let's start with the, let's make our little t-chart. Now, I'm not going to make a TT chart because I'd like you to really try to do this math in your head, which you can, or you can do some side math. 1, 2, 3, 4, 5, 6, 7. Now, what number do you think we're going to start with? 0 or -2? Why -2? Let's try that again. Go ahead. -4, somebody says. Yes. You are not allowed to have a 0 in the denominator. So you are going in the denominator. So what number do you put in the denominator to make it 0? -2. That's correct. That's accurate. -2. Now, I am purposely not giving you a graph, and I even took out my little graph pad that Sophie gave to me. But from here on out, you guys are going to draw your own graph because some of the graphs are not going to be centered around 0, 0 because of the translations. So you're going to want to, so I'm thinking on the next assessment, I won't even give you a graph. I just leave a blank spot so that you can do this. So you know where to start here. -2, 1. Now let's pick 3 numbers up and 3 numbers down. Right? So starting at the asymptote, 3 numbers up and 3 numbers down. All right, let's do our mental math here. Start with -1. -1 plus 2. 1, -4 divided by 1, -1, -5. Oh, I wrote my table wrong. Sorry, guys. It's supposed to be flipped. Positive, negative, same thing. Okay, let's do 0. What's the question? Hold up. What's the question? No, because this is undefined. It's not 0. It can't even exist. Yeah, it doesn't exist. Okay, let's put in 0. No, no problem. That's a good question. -4 divided by 2, -1, -3. Okay, 1 plus 2, I'm going to write it here, -4/3 -1. So let's think about this without converting it. Let's just use logic. What makes sense? -1 1/3 -1 is -4/3 is -1 1/3. -1 1/3 minus another one, -2 1/3. It's easier to graph this way. Improper or proper fraction, either way, it's just easier to graph this way. Okay, -3, let's try that. -3 plus 1, -4/-1, -1, 3. -4 plus 2, -4 divided by -2. 2 minus 1. Okay. -5 plus 2. So now I'm going to do side work. 4/3 minus 1. So 1 1/3 positive minus 1 1/3. Okay. Here's how you draw your graph. And this is the part that our athlete needs to listen to as you watch this video. How do I draw my graph? This is where it's going to get tricky because you're not just going to do a normal grid. You have to plan and look at it. Look at my X values. I have more negatives than I do positives. So you don't want to center the Y axis. Now let's look at the Y values. My Y values, or these go farther, my Y values go down to -5. And the highest one I have here is +3. Okay, so it goes down to -5. So let's see, draw a line. And I may have to change it and adjust it. Now there's more negatives. See, this goes to -5 and I'm only going to +1 for here. So I'll put this around here. And it goes down to -5 up to +3. Now you may have to do more points to get a clearer picture. Let's first draw in your asymptotes. What's my first asymptote? -2. So at -2, let me draw these. You need to label your graph. I was working with someone today and they don't have their graph labeled. Just something like that even. So at -2, you have your asymptote. What's my equation? X equals -2. Okay, that's what I know. That's where we're starting. Okay, now let's plot our points. I can start here. -3, +3. -4, +1. -5, 1/3. Now, I'm warning you, it looks like the asymptote is X equals 0. That's what it looks like. But because of the transformation, it's going to be shifted down 1. We just didn't pick enough points, and we'll pick another point, okay, so that you'll see that it's not going to be the x-axis. Let's finish graphing it. -1, -5, 0, -3, 1, 2, 3. -1, -2 1/3. Aha. Now here it's looking like my asymptote might be -2 because it looks like it's getting really close. Okay, so I'm actually going to put in 2 more points just to make sure. Why? Because I want to take my time. I want to make sure that it's accurate. I'm going to plug in 3, 4, 5, 6, -6, because I can do it in my head. -6 plus 2. -4 divided by -4. 1 minus 1. Oh, look at that. That is not the asymptote because there's a point there. And I can go the other way and I can plug in 2. 2 plus 2. -4 divided by 4. -1 minus 1. -2. Ha. Now it's curving out, but it is definitely crossing that axis. Now, knowing that this is shifted down, this whole graph is going to be shifted down 1. Where do you think the asymptote is? Y equals -1. Very good. Look, it's right there. It tells you. I just wanted you to figure it out. Y equals -1. On why the asymptote is -1?
Oh, actually, I think that's
Someone explain it. Why is the asymptote -1? The transformation right here, the translation right here, down. The whole graph shifts down 1. So in the work that you guys did yesterday, all the work that you guys did, right, and get your A or B on it, there's nothing over here because it's +0. So that's why the 0 is the asymptote. And it gets a little more complicated than that, but that's the basic things for now. Okay, now go ahead. We'll get there. Okay, let's sketch it now. Knowing that it's approaching my asymptotes, but not crossing the asymptotes, you can draw your graph into a nice smooth curve. I look at some of your posters around the rooms and I don't see smooth lines. Just saying, they're supposed to be smooth lines. Okay. Now let's put the parent function in. Someone asked me about the parent function. Should I just memorize the points? Yes, you should just memorize the points and what it looks like. And you have the points on your worksheet from yesterday. So 4, 1, 2, 3, 4, 1/4, 2, 1/2, 1, 1, 1/2, 2, 4, 4. So 1, 1. -2 1/2, 4 4, 1/2, -2 4 4. Okay, what are we missing? We're missing stuff. This is not A. Label them. Very good. So this is f of x. This one is g of x. What else are we missing? Domain and range. Okay. I am now going to teach you how to write the domain and range in the pre-calculus the way you're going to see it in that class. It is correct the way that we talked about it yesterday, but I just want to get you guys prepared for years to come. So, and I think I did it last semester. Domain, squiggly line, x, such that. So look at my x values at my red, only look at the red function here, g of x. What values for x does it exist or not exist? Values of x. Look at the x values. If I was standing here and I look up or down, do I see the value? Do I see my function? If I stand here, do I look up and down? So what are my values for x? All real numbers except zero's right here. Look, I'm standing here at 0. This graph exists. -1, I'm here. Look, right here's -1. I look down, there's my graph. -2. So watch how you write this. X does not equal -2. Squiggly line, bracket. Writing it this way says, you don't need to write all real numbers. Just by saying x does not equal -2 means that it's all numbers except for -2. So range is going to be the same thing. Y such that y is what? Does not equal -1. Let me point something out to you, squiggly bracket. Take a look at this. See my domain and range? Take a look at my asymptotes. My asymptote is x equals -2, but my domain is x does not equal -2. See the pattern? Range here is y equals -1. Over here, y does not equal -1. Okay, are we done? Write the transformation. Correct. Math makes sense. I want you to do well. Okay. So what am I missing? Transformations. Tell me the transformation. Good. First one, reflection. over the x-axis. I love thinking back to first semester, August, all of you guys dying with reflections. Huh? What? I don't understand. Doing our little dances. Right? So you know what remembers their dances? No one's looking at me. You don't remember your dances? Yes, positives and negatives. Okay, what's the next one besides reflection? Good. Vertical stretch by a factor of 4. What's the next one? You can even just look at the two graphs and you can tell, but also look at the equation. Horizontal translation 2 units to the left. And I want you to look at the equation so that you can look at the equation and see the transformation as well. Okay, next. Vertical translation. Oh, I'm running out of pen here. Vertical translation. Where? One, oh, what's that color? Purple. 1 unit down. Okay, do we have all 7 things? Are the asymptotes drawn? Are they labeled? Are the parent, is the parent function there? Are those labeled? Are there arrows? Did you write your transformations? Did you write the domain and range? Did you show your work for it? Kind of, yes. We haven't gotten there. Let's just start with these basic ones first. I can't wrap my brain around that. We will get there. Okay, we will get there. Now, yes. Shh, guys, hush. Oh yeah. So my mistake first semester, which now I'm learning and I'm trying to help and moving forward, was I got so excited about seeing you first, number 1, in person, but number 2, to get you to use the calculators because I was tired of using Desmos online for 2 years. But then it took away from you being able to graph this by hand. So hopefully now you guys are getting a lot better at graphing it by hand. We're going to be moving. You guys are, we're going to have like 3 asymptotes, 4 asymptotes. You're like, wow, how do I draw a function avoiding 4 asymptotes, right? So we're going to get there. Right now we just have 2. Okay. We're going to do not one more. What time? 1:40. Oh yeah. Yeah, we're not going to do one more because we're not going to have time. Your homework, you need to do it on paper. 7-2, what are the numbers there? 11 to 17. Oops. 11 to 17 odd. Now, I gave you the odds. And this, thank you for watching.